Okay, so 610, talk about paired functions. So this first one is linear. Y equals x. So y equals 2x plus 3. Y equals negative 5 fourths x plus 17. Anything where x is to the first power is linear. Okay, this one is quadratic. This is y equals anything with x squared. That's the important part. That shape here, this is called a parabola. This third one over here is a square root. I'm just going to abbreviate it. Y equals the square root of x. The v is absolute value, which I'm also going to just abbreviate. Absolute value, y equals the absolute value of x. So it's similar to a parabola, except it's a v instead of a u. This is an exponential. And the important part is the variable is up in the exponent. The variable is in the exponent. The 2 could be a 2, a 3, a 5. The base can be any number. It can even be a fraction. It could be 1/2 to the x or whatever. But the important part is it's an exponential because the exponent is your variable. And this one right here is called a cubic function, and that's y equals x to the third power. So that 3 is the important part there. So the 2 is important here, the 1 is important here. All right. Let's look and see how they are transformed, or also known as changed. Okay, so it says name the vertex of each parabola, given the equation, then graph each. Describe in words how the original function was transformed to get the new function. Use words like stretch, compress, we talked about the other day, narrower, wider, stuff like that. Okay. So we just did vertex form. Let's identify the vertex for this one. What is the vertex for this one? Good. Opposite of this number and exactly this number. Okay? So that's the vertex. Okay? Now, this number here is important. It moves it left 2. This 1 here moves it up 1. So in other words, the vertex is going to move from here over to up 1. Okay? So there's the new vertex. The vertex moves left 2 and up 1. Now the 3, remember we talked about the A? The A means it's going to be narrower.
Wait, how do we find that out again?
It's right here.
Like, is it like the bigger the number, the
You noticed the other day, if it's bigger than 1, it's going to make it narrower. Okay? If it's a fraction between 0 and 1, it makes it wider. So 1/2 makes it wider. 1/4 makes it even wider. 1/16 makes it even more like a bowl. Okay? So we're not going to look for points. We're just going to draw the same kind of thing. Just kind of make it a little narrower. Just make it clearly narrower than that one that was already there. Okay? What's the vertex on this one going to be?
2, 1.
positive 2 and 1. Which means what happened? It moved right 2 and up 1. So it moved over here, right 2 and up 1. Now, the negative let's say negative A. Negative A flips it. So instead of a happy parabola, it's a frown. It's going down. And the 3, A, let's say A equals 3 just to be consistent. A equals 3 makes it narrower. So when we go to graph this, we take our new vertex. We're going to make sure we do it narrower like we just did, but we're also going to go down like this. So just make it clearly narrower. We're not going for specific points here. Go for clearly narrower and just upside down. Okay, so the vertex on this one is going to be what? Negative 2, negative 1. So that means it's going to move left 2 and down 1. So left 2 and down 1. So there's my new vertex. Now my A is positive, so it's going to be a smile. It's going to be a happy parabola. All right? But A equals 0.3, very good, is going to make it wider. So when I make this thing, I want to clearly make, even if I exaggerate, I'd rather exaggerate and make it way wider. Okay, and last but not least, what's the vertex on this one going to be? 2, negative 1, which means right 2, down 1. The negative A is going to flip it. And the A equals 0.3 is going to make it wider. So we're going to go right 2, down 1. We're going to do it upside down and clearly exaggerate how much wider it is. All right, so this can be applied to all functions. So, 1, use the parent function of the shape. Okay? 2, this shifts it right or left. This shifts it up or down. This tells you whether it's going to be happy or sad, up or down, and also whether it's going to be wider or narrower. Okay, let's look at this first one. We have a linear function. Has the tilt of this line changed from here to here? Does the slope look like it changed? Has the slope changed? Okay, it moved up and down, but is the slope changed? I mean, look at it.
It looks pretty much the same to me.
Right. Looks pretty much the same, doesn't it? It's just like you just said, it's literally just dropped down. Okay? So this one is just down. We use the new abbreviation, DN. Down. Okay? It's not, the slope hasn't changed. So it's not wider, narrower, or anything like that. It's not going in a different direction, so it hasn't flipped. It's just down. Now, here's our parent function, right here. And here's our newer one. So let's talk about all the changes that happened to it. What's one thing that happened to it? It did flip. Very good. It went from positive to negative absolute value.
It's narrow.
It's skinnier, narrower. Very good. Okay. What happened to the vertex? What did the vertex do? From here to here.
Left down.
Left and down.
LD.
Left 5, down 4. I'm telling you, so you don't have to count. It's kind of pain, it's tiny. But it is left 5 and down 4. Alright. So, this cubic function. Okay, first off, what between here and here, what happened to the vertex?
It shifted left and down.
No,
Is that shifted right?
It's right.
From black to red, what happened?
It went down.
It went down?
Oh, it went to the right.
It went to the right.
How do you know which one?
Yeah, the solid line versus the dotted line.
I was going like
We're looking at this dot compared to this dot.
I went right. You're upright.
It moved right 5.
Yeah.
Now, what else happened to the snake? The squiggle.
It twisted.
No, it's still going from left to
It's
right.
wider.
It's wider.
Look, now you're riding it better. Or
It's getting wider. Okay? Right 5. It's hard to count, so I'm just telling you what it is. Okay, so here's my parent graph. Here's my transformation.
It went down.
Here is this vertex, here is this vertex. From blue to red.
Oh, it went up.
Okay, so it went up. And specifically, it went up 4.
Yeah, I can't see the.
That's what I'm telling you.
Good for you. Oh, yeah.
Now, does it look any wider or narrower?
No.
It does not. But what is it? It just flipped. Good.
What?
All right. So for each of these, sketch the parent function, then the new transform function. Okay. So y equals x. Whatever y is, x is. So that's 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. This is a straight diagonal like so. It's a straight diagonal. Now, one thing we already know, we know from doing mx plus b, b is where we...
This is your intersection on
B is where we begin. B is where we begin. So we actually put a dot. So we're actually going to put a dot at -1. My board needs to be
I
recalibrated.
really can't see, so I'm just putting it down.
We're going to put a dot at -1. Okay? And the slope is up 3, right 1. Okay? So there's that one. It's a little steeper. Okay? And it drops down 1. Okay, square root of x looks something like this. We're not going to be exact. That's the square root. That's from our parent page. Okay, that's the square root function. Now, plus 3. Which way does it move? Left or right? But it's underneath the radical, so it moves left. So we're actually going to be out here, starting 1, 2, 3, and it's going to be flipped. like this. And all we're going to do is drop down 3. That's the only change to it. So it looks almost exactly the same. It's just down 3. All right, remember, absolute value looks like a V. Corner to corner. In fact, this right here, this part is y equals x. We just did that. But then instead of going down into quadrant 3, it bounces back up into quadrant 2. Now, what's happening to the vertex? Where's the vertex going? Down 5. So my vertex is going to be right there. Now, what's the negative going to do to it? Flip it. What's the 100 going to do to it?
Make it
Down.
narrow.
Make it wide.
No, narrow. Oh, wow.
Narrow, really narrow. 100 is going to make it really narrow.
Oh, that's too.
Okay, what's the vertex on this one? What's the vertex on this one? Well, that's part of it. What's this number? 2. So 2 negative 3. Right there. Okay? Now it's a parabola, right? So, I'm sorry, my bad. That's the transfer one. So first off, remember our parent function looks something like that. Okay? So this is going to move it right 2 and down 3. Now it's going to be wider or narrower? Wider. Flipped or not? So just make it obviously wider. X cubed is a snake, kind of comes up through 0 and goes like that. That's the general shape of that. Let's change this from +1 to +10. What's it going to do to it? It's going to go up and hit through 10. That's where it's going to turn. Make the 1 a 10. So making it a 1 is going to make it like so close it's going to be hard to tell the difference. So instead of cutting through 0, midway through its body, it's going to cut through 10 and make that turn. Okay, we're going to really just roughly sketch this. What's the +1 going to do to it? The vertex. No, it's inside the parentheses.
The 1 is gonna make it go up.
No.
I mean, right.
If I put a +1 out here, that would make it move up.
It's gonna go right.
Remember, if it's in here, it goes opposite. Opposite. Left. 1. So my new point is going to be right there, -1. Now, with the 25, it's going to be wider or narrower than a normal one. So it's going to make it kind of a really narrow one starting at -1, 0. Okay, where's the vertex starting here? Left or right? Right. So put a dot at 2. Now, our V, is it going to be wider or narrower? 0.05. Wider. So we're starting here, I'm going to make this just a wide one like that. Now on this one, it's kind of funky to think what happens, but let's think about what the parent one is. The parent one looks like this. So the negative is going to do what to it? Right. So it's going to actually go up from this side, come through and go up that way. Okay, so instead of starting lower left and curving up right, it's going to start lower right and curve up left. Okay, so 2 to the x. Is it moving left or right, up or down? there anything in the parentheses here? Is there anything out here?
No.
No. So the 40 is just making it do what?
It's kind of like
Narrower, or climb faster. So instead of being like out here, like this, like we talked about the parent graph, it's going to be more like this. It's going to make a more dramatic climb. It's going to climb faster. Now in this one, this is mx plus b, so where are we going to begin? -3, right? And instead of going this way, writing your name uphill, it's going to go this way, and it's just going to be a really steep line like that. We talked about this last week. Remember, write your name on it. If you wrote your name on this, you'd be going downhill. Now, two things are happening to this vertex. What's happening first? What's this going to do to it?
right, left,
Right? No, right is opposite. So right 2,
down 5.
down 5. So it's going to go, instead of being here, it's going to go right 2, down 5, which is right here. And then it's just going to do that little curvy thing like that.